Hello and welcome to Chem Talk with Hunter. Today we'll be discussing ionic compounds, what they are very briefly, and how to write them. So first thing to understand about an ionic compound is that it occurs between a cation and an anion. So that's just a fancy way of saying a positive charge and a negative charge. So that means an ionic compound would form between a metal and a nonmetal. Now, sorry, couldn't fit that there. So there's two types of main metals. You have a fixed charged metal, or you have a transition metal. Now, a transition metal is just a metal that can form multiple charges. So if you're writing an ionic compound and the problem gives you an element with, let's say, a Roman numeral, we'll say 1, 2, or 3, although you can get ones with more, higher up, you can get even 5. That's telling you the charge of the metal. So the Roman numeral denotes the charge of the metal. So just be careful of that. If you're given a transition metal bond and it doesn't specify what type of charge it is, you have to write ambiguous or not specific enough, because teachers will do that in high school to test your knowledge. So what we're going to do here first is write a simple ionic compound and just review how to do that. So write the ionic compound that occurs between potassium metal and oxygen gas. So now would be a good time to get out your periodic table if you don't have your charges memorized. And if you're new to chemistry, you probably won't, and that's perfectly normal. So potassium metal has a +1 charge, while oxygen gas has a -2 charge. Now, there's a couple ways to think about how to balance charges. Your goal when writing an ionic compound is to get the charges to balance to 0. So if I have an element with a +1 charge, an element with a -2 charge, or a -2 charge, what I need to do is get the smaller one to balance out the bigger one. Now, the easiest way to conceptualize this is to just swap the charges. So what I mean by that is you bring the 1 down for oxygen, so you don't have to write the 1, but you bring the 2 down for potassium, and that is your compound. Now, how I did that, like I said, is swap the charges. So if I was to look at the charges of this compound now, or the oxidation numbers, potassium has a +2 charge, because we have a potassium, which has a +1 charge, and we have 2 of them. So that's a +2 charge, and oxygen has a -2. So that balances to 0, which means we did it right. So potassium oxide is how you name it, and it has the following formula. Potassium oxide. Only 1 T, my bad. Okay. Next, we're looking at a little bit more of an involved example, but nothing terrible. We see a polyatomic ion. Now, I will do a remedial video about polyatomic ions, but for now, you should know that they come as a package. So your teacher might make you memorize these or give you a table. But I know that phosphate has the formula of PO4 and has a charge of -3. Now, I also know that calcium is a metal and has a charge of +2. So now that you know the swap and dance little trick, you swap your charges. So you bring down a 3 for calcium, and now you bring down a 2 for phosphate. But notice what I'm going to do. I'm going to put the polyatomic ion in parentheses. That just helps us to organize the compound. It's also a basic rule of writing compounds, is you want to put the polyatomic ions in parentheses. So that is the formula calcium phosphate. If you want to double check, you can see you have 3 calcium. So that means you have a +6 charge over here. And you have 2 phosphate ions, which means if each one's -3, you have a -6 charge there, which equals 0, which means you did it right. Moving right along here. Now we're looking at something that occurs, with a transition metal. We're given, write the ionic compound iron 2 nitrate. So like I said in the beginning, iron's a transition metal, has the symbol of Fe. And here we're seeing that they're telling us its charge is +2 with the Roman numeral 2. Now, nitrate is also another polyatomic ion, very common, has a -1 charge. So we do our swap, and we get iron to nitrate. So I brought down the 2 for nitrate, and I put it in parentheses. So if you would like, you can always double check. Sometimes you don't have enough time on a test, but if you want to double check, you see that iron has a +2 charge, nitrate has a -1, but we have 2 of them. So that gives us a -2 charge. So +2 plus -2 gives us 0, and that's what we want. Okay, another good example is sodium permanganate. Permanganate's another polyatomic ion, and I know it has the formula of MnO4, has a -1 charge. And look, it's with sodium, and that's an easy example because sodium has a +1 charge. So there's no swap and dance here. Well, you could, but you don't really have to because they balance each other out. Sodium has a +1 charge, but permanganate has a -1, and that gives us 0. So check, please. Done there. Last one here is another transition metal bond, and it's between tin 2 and chlorine gas. So we have tin, Sn, and we're told it has a +2 charge, and we're given chlorine. Now we know chlorine has a -1, so we swap, and we get SnCl2, tin 2 chloride. Tin has a +2 charge, and chlorine has a -1, and we have 2 of them. So that gives us 0, which means we did it right. So these are the basics of ionic compounds, how to write them, and how to name them as well. Put in the comments any other topics you'd like me to cover. I'll be making videos regularly. And if you have any questions about ionic compounds, write it in the comment section. I'll get back to you shortly. Thanks so much for watching.